Hello everyone, this is the Unit 2 review sheet, Part 1, 20 questions. All will be multiple choice on the actual test. So the graph of this function, number 1, is shown below, and here's the graph. So it says describe each section in the graph, linear, nonlinear, increasing, decreasing. So I'm going to highlight section N. So what is that? Is it linear? Nonlinear. So first, if you said linear, you're correct. Obviously, it's a straight line. That's why it's linear. And is that increasing or decreasing? Yep. Because it's going up from left to right, it is increasing. So that would have a positive slope. Section P is this section right here. So, is that linear or nonlinear? Yeah, if you said linear, you're correct. Is that increasing or decreasing? Increasing up, decreasing down? Yes, increasing. And that would have a positive slope. The next section, section Q, is that. Is that linear or nonlinear? Yep, if you said linear, you're correct. And is that increasing or decreasing? Or neither? Right? It's neither. So this has a slope of 0. And that is a horizontal line. Horizontal lines have a slope of 0. Just think of that O in horizontal as 0 slope. Horizontal lines, 0 slope. And the last section right now is R. And we have linear, obviously. And it's increasing. Right, and that takes care of number 1. Number 2, the owner of a coffee shop compared the amount of hot coffee per day in fluid ounces sold and the daily high temperature in degrees Fahrenheit per day. Her data are, the data is shown in the scatter plot below. So we're looking at the scatter plot, draw a line of best fit. So anytime you draw a line of best fit, remember it has to be a straight line, and it begins at that y-axis, goes through the center of all of the points. And I'm going to move that a little bit down, and that is where I want to start that's where I want. Please use a ruler for this because I think it's the easiest way to go as far as using a ruler. You draw a straight line, you get to see the line before, like with the ruler, you can put the ruler down, you can see exactly where you want to draw it and if it's good enough. And that is my trend line, my line of best fit. Remember, line of best fit is also known as a trend line. It's the same thing. Okay, how many fluid ounces would the coffee shop sell if the temperature is 90 degrees? So it's asking you to use that trend line as a prediction. So every time that you do this, we really want you to draw what it is. It's like a dotted line up to where the trend line hits. This is 90 degrees. So it hits the trend line right there. And then I'm going to go across and draw my dotted line. And it's just going to be above 300. Well, I would say in the middle is 350, so I'm going to say it's around 310. According to my trend line, I could even say 3 320. 320 degrees Fahrenheit. No, sorry. That is not degrees. That is ounces. Ounces. 320 ounces sold when it's 90 degrees out. How many fluid ounces would a coffee shop sell if the temperature was 40 degrees? I'm going to go to 40, and I'm going to use that trend line. Again, I'm going to go all the way up to the trend line and then go across. And I'm going to say about 630. Your answers might be a little different than my answers because of differences in trend lines drawn, right? But it should be around the same amount that I'm getting. How many fluid ounces would the coffee shop sell if the temperature was 0 degrees? All right, so 0 degrees, we're going to go up from 0. We don't have to go over to the left because we're just going to go straight up to our trend line around there, and that's like 850 fluid ounces. All right, use your trend line to predict values. And that's number 2. Number 3, which line represents the best fit for the scatter plot? In practice, draw a trend line on the scatter plot given. So I'm going to draw my trend line. I'm going to go from here to here. Right in the center of all of those points. Right, that's my trend line, and I think that is a good trend line. To the center of all the points. Right, so does this scatter plot have a positive or negative association? It is going up, so it's positive. Right? It's going up, so it's positive. So it's positive association. Is the data on the scatter plot does the data on the scatter plot represent a linear or nonlinear function? Is it a straight line as far as scatter plots go? Because scatter plots are scattered all over the place anyway. But we're talking about, can you draw a trend line here that is completely straight? And yes, you can. All right, so if you're saying yes, this word line, and this is no line, linear, is it linear? Yes, it is. It's a linear function. It's linear because it's straight. Does this have an outlier? No. An outlier says draw an outlier. An outlier would have to be somewhere around here or over here, far away from the data, and circle it. So we're going to circle my outlier, and that is question number 3. Question number 4, find the slope and the y-intercept of the linear equation. Remember, every linear equation, y equals mx plus b, the m is the number before x, and the b is the other number. So the m is the slope. What is the m of this equation here? If you said 1/3, yes, you are correct. 1/3, so that means c is out. M is 1/3. And b is the other number right here is -5. B is 1/3. This is -1/3. 1/3, -5. D is your answer. Out. Right. Find the slope of the line that passes through these points right here. What is the slope formula? Slope formula, y2 minus y1 over x2 minus x1. So you write that formula down every single time you use it. The second thing you must do is label. This is my first x, so it's x1. This is my first y I see, this is y1. This is my second x, this is x2, and this is y2. Now all I have to do is substitute in. When I set up my formula, m equals, put the fraction line down, and then put the minus symbols in from, and that the minus signs are from the formula themselves. So I have y2 minus y1, which is 9 minus 7. And then I have 3 minus a negative 3. 3 minus a negative 3, because that x1 is a negative 3. So we are going to take this calculator and set things up. We are going to set things up right now by pressing this fraction symbol right here on the button on the calculator, 9 minus 7, and then 3 minus a negative 3. Notice that I didn't even have to change that minus negative to a positive, which is what happens with keep change. We're using the calculator, so we press enter. It gives you 2 over 6, but that's not going to be your answer, because guess why? You have to reduce that fraction. Luckily, the calculator will reduce the fraction by pressing the simp button and then enter. So M final answer is 1 over 3. That is a positive slope. Rise of 1, a run of 3. So what I'm saying right here is this: once you have a minus negative, that is positive. All right, you just change it right away. You see the double negative. All right, it's a minus, a negative. Change it. All right, so number 6, find the equation of a line that has a slope of 4. I'm going to write it down. M equals 4. And a y-intercept. Y-intercept is B of negative 2. Find the equation of the line. What's the equation of any line? Yep. Y equals mx plus b. So the m is 4. All we have to do is substitute in. This 4 is going to go here. This negative 2 is going to go there. So this is y equals 4x, 4 going in for the m, and minus 2 for the b. That's the equation of that line. Number 7, a bicycle club went on a 6-hour ride. That's long for a bicycle club. The graph below shows the relationship between the number of hours spent on the trails and the number of miles traveled. What happened in the 3 to 4 hour time period? So I am going to draw a dotted line up and up from 4. What happened during this time period? What's going on there? So they left. This is distance in miles. This is time that's going by. They're riding. They're going 10 miles in 1 hour. They're still riding. They're still riding. They passed the 20-mile mark. Past 30 miles. And then at like 33 or 32 miles, they stop. An hour goes by and no miles. They go no miles. So what's happening during that hour? Okay, so they stopped for a break or for something to eat, time is going by, and the miles are staying the same. So if you want to go ahead and copy that down or just check your answers, they stopped for a break right here at the 3-hour mark, and they maybe got something to eat, went to lunch, whatever it is. Time is going by and the miles are staying the same. That's number 7. Number 8, the graph of a function is shown below. For which interval of x is the function decreasing and linear? This is tricky, all right? But let's go ahead and see if we could figure this out. We need something that's decreasing and linear. All of this looks linear. So everything is linear here in this graph, right? Decreasing, though, that means we have to look for something that's going down. Okay, 0 to 10. Here's 0. 0 to 10 is this right here. That's increasing. So that's not it. And then from 10 to 15, which is 10 to 15, which is right here. 10 to 15, we're going to say that's that. That's not decreasing. Then from 15 to 40, decreasing. Yes, that is the one that is going down. I don't have to look any further. That is decreasing. Between 15 and 40. So that's C. Number 9, find the slope and y-intercept of the linear function below. So we have 3x plus 5y equals 10. To find the slope and the y-intercept, you must put it in y equals mx plus b format. So the first thing that we do, I'm just going to rewrite it. I don't know why I'm rewriting it, but I am. The first thing we want to do is move that 3x over to the other side of the equal sign, minus 3x. Minus 3x. This cancels. We have 5y equals, and I hope you don't get confused. I'm going to put that negative 3x first, plus 10. One last step, and we are going to solve. The operation that attaches that 5 and the y is multiplication. The opposite of that, the inverse operation, is division. So we're going to divide by 5. So we're dividing by 5. All right, so just remember, you're keeping the fraction. Negative 3 over 5. So y equals negative 3 over 5. Don't forget the x. And then 10 divided by 5 is obviously 2. So the slope is negative 3 over 5. And the y-intercept is 2. You're going to have to do this number of times during this exam. So make sure that you know how to solve for y. Y equals mx plus b. Then you could identify the slope. Then you could identify the y-intercept. Then you could graph it. You could do anything with it. So just realize that is very important. So number 10. Which association correlation best describes the data? Draw a line of best fit. We're going to draw a line of best fit on all of these. So we're going to start with the y on that y-axis and draw a line of best fit down through the center of all of the points, just right there. All right, so does this have an outlier? No, it doesn't. So this is a negative trend. Negative. And I would say also this is linear. And just to answer if it's strong or weak, this is like kind of like one of these in-between ones. I'm going to put strong, but if you put weak, it'll, I see exactly why you're saying that. The points are a little bit far away from the trend line. So it's a little bit difficult, but if you said strong because you think they're closer to the trend line, then that's fine too. I'm going to put strong. So here is my trend line for this scatter plot, going through all the center of all of the points as best as I could. So that is going up from left to right. This one was going down. That's why I said it was a negative trend. This one's going up from left to right. That's why I'm going to say it's positive. And this is also linear. And this is definitely strong. And no, it has no outlier. One more. Again, I am going to draw that straight line through the center of all of my points. All right, I'm going to fix it up just a little bit right there. Doesn't have to start from 0, 0, but that's where I'm going to leave it. All right, I'm getting crazy here. All right, so this is also going up, and that means it is a positive trend. This is also linear. It doesn't curve. And if it curved, by the way, in a scatter plot, don't draw the trend line. Trend lines are straight. All right, so linear, and it is strong because all of the points are hovering or clustered. They use that word clustered a lot around the trend line. Does this have an outlier? Yes, it does. We're going to circle that outlier right here. It's a point that is apart from the rest of the data. So remember, if they ask you about an outlier like that, then they're talking about a point that is far away from the rest of the data, just like this one right here, and that ends number 10. Number 11, I know people are going to have trouble with this one, but don't have any trouble, right? Just listen to what I'm saying. It says find the equation of this line using the points listed in the table. Equation. What's the equation of any line? Y equals mx plus b. Yes, y equals mx plus b. The slope, the two things that you need from this table are the slope and the y-intercept. Now think about it. Slope and y-intercept. Look at this table. Is there a y-intercept that is in the table right in front of you? All right, so listen, say you're looking at the table, you forget what the rule is that we told you. We're going to start graphing. So we're going to sketch it. Like just draw an x and y axis. And -8, -42 would be somewhere down here. Don't sketch that one. That's not the y-intercept. So that's out. -3, -17 is all the way down here. Is that the y-intercept? No. 0, -2. Is that the y-intercept? Yes. -2b is right here. When x is 0, the other number, that y coordinate, is the y-intercept. So we're going to put down a -2. Just sketch it. Sketch it. It gets you the answer a lot of times. So now we have to get a slope formula. Right? We have points here. We have coordinates. So we're going to use not rise over run. We're going to use y2 minus y1 over x2 minus x1. Right? And we're going to label in this table. This is x1. This is y1. This is x2. This is y2. By the way, if you really feel more comfortable taking them out and putting them like this is 0, -2, and this is 6, 28. And by the way, you could use any points that you want. I want to stay away from the negatives. Even with the calculator, I'm staying away from the negatives. So if you want to rewrite them like that, then that's fine. And you could go x1, y1, x2, y2. I don't bother. I just put them directly, put my labels directly on the table itself. Set up your slope with the minus signs. And we're going to do y2, which is 28, minus y1, which is -2. See that double negative? X2 minus x1. Grab your calculator. We have 28 minus a -2. Put it in just like that. And then 6 minus 0. Enter. 5. Slope is 5. And again, I'm just going to remind you that the back-to-back, the minus negative, you just add them up. You change them to positive. So what is the equation of this line? Y equals mx plus b. Y equals 5x, because 5 is my slope, minus 2. That is the equation. All right, and that is that. It's a good question. I know a lot of people will have trouble with it, but try not to. The graph picture below is Sandy's water dish. Starts with 400 milliliters of water, 400, and goes down to 0 where this dog was thirsty. What is one possible interpretation of the section of the graph 30 from 30 to 60? So here's 30, asking about this horizontal section right here. Sandy was drinking the water between 30 and 60. Was it going down in this section? No, she wasn't drinking. Sandy stopped drinking to investigate the noise. She did stop drinking because it stayed at that 300. So that is your answer. Sandy tipped the bowl over. If she tipped the bowl over, it would go straight down to 0. And the owner filled up the bowl, then it would go up. This line, this graph is not going up, is never a positive. This is out, this is out. B is your answer. All right, number 13. Find the slope of the slope of this line graph below. All right. So I need 2 points. They give you the 2 points. My slope formula is rise over run. So I'm going to use the points they give me. By the way, as I'm drawing this, I know from left to right that this is going down. That means I should have what type of slope? If you said negative slope, then you are correct. This is a negative slope. So I'm going to set that up and just remind myself that I'm going to have a negative. All right, so what is my rise? I'm going to count 1, 2, 3, 4. And since I'm going down, I'm just going to put -4. 1, 2, 3, 4, 5, 6. My run is 6. It is -4 over 6. So if you take your calculator and put -4, put the calculator there, -4 over 6, and click it, enter, it will give you the same thing back. But then you press this simp button and you press enter, and it's -2 over 3 as a final answer. All right. Number 14, what can you conclude about the graph of a line given by this equation? The line has a slope of 5. Well, let me see. Slope is not 5, it's -5. That's out. The y-intercept is 0, -5. Well, what is the y-intercept? I don't see anything there. It's 0. So this is saying that the y-intercept is -5, though. So that's out. And if you get confused, just sketch it. And a small sketch, 0, -5 is down here. So that's -5. It's saying that it has 0, -5. That's not it. This is not that. So cross it out. The line passes through the origin. Yes, it does. That's the answer. The line rises from left to right. It doesn't rise from left to right. This is a negative slope. Negative slopes decrease from left to right. Rises would be a positive slope. So that is out as well. C is your answer. And that's it. Number 15, the cost to rent a boat includes an initial fee. Let me get my highlighter out. Initial fee of $9 plus $6.50 per hour. So let's go ahead and put together the y equals mx plus b. The number that is happening over and over and over again, that is your rate. That's the number that is going to get charged over and over and over again. Not the one that you're going to pay only once. So the initial fee is the b, and this is the slope. Usually it says per. Sometimes both of them will say per, and it's a little confusing. But when you have plus $6.50 per hour, and that's what you're going to get charged over and over and over again, well, that's a little bit of an easier question. So that is my slope. So I'm going to put that in for the M. And I'm going to put that initial fee in as my B. So B is your answer. Okay, and it's not putting 6.5, it's 0. It should be 6.50 there, because we're talking about money, and money's rounded to the nearest hundredth. Right, so 100 pennies in a dollar, that's why. 16, the graph below models the cost of renting a car. What's the initial fee and the cost per hour? It's just asking you for the slope and the y-intercept. So initial fee is your y-intercept. The cost per hour is the slope. Let's figure it out. Y-intercept. 15 gallons in the tank. Initial amount, 15 gallons. Could be this one. Initial amount, 0. Wrong. Initial amount, 7. Wrong. Initial amount, 15. Could be this one. You canceled out 2 out of the 4. It's great. All right. So you have a really good chance of getting this correct. Now they're just saying 25 miles per gallon or 50 miles per gallon. Let's figure out the slope. I'm going to pick the y-intercept that I already have, and I'm going to pick this point right here. I'm going to make a point on that line because I can, and it has whole number coordinates. So I'm going to go down and to the right. So I'm going to say that this is not 1, this is 25. 25 miles driven, 1 gallon for every 25 miles per gallon. That's MPG. 25 miles per gallon. D is your answer. It's not 50 miles per gallon. It's 25 miles per gallon. All right, so D is your answer. 17. Identify the correlation for each of the scatter plots below. So first, we're going to draw trend lines. So the trend line right now going across this way. So we're going to say right here for this one is that the slope, this is a horizontal line, the slope is 0. They didn't ask that, but the correlation, it is linear and strong. Right, the slope is 0. There is no correlation for this one. The points are all over the place. They're scattered all over. No correlation, no association, no correlation. Scattered. You can't draw a trend line on this because they're scattered all over the place. All right, so that's it. Trend line here, going through the center of all the points. This right here, I'm going to move this down a little bit. Right there, yeah, that's it right there. That's good. All right, is a negative association. And this is linear, straight, right? And this is a strong association because they're scattered around, that the points are clustered around that trend line, right? They're clustered in like tightly in that trend line. That means it's strong. Okay, one more. Number 17, and we're going to draw a trend line. So that trend line is going up. Move this down a little bit. There we go. All right. So this is up. So this is a positive association. Positive association. It is linear, but I am going to put that this is weak. And it's weak because the points are further away from the trend line. All right, like this one and this one, that's pretty far away. So we're going to say this has a weak association right there instead of strong. Strong is clustered around the trend line. Weak is not so clustered around. Just more of like a scattered look about it. All right, so here we go. Number 18, which point in the scatter plot appears to be an outlier? This one. So there's the outlier, and I'm going to say that's the 18th week paycheck at 165. Remember when I was drawing these dotted lines, right there matches up with 165. D is your answer. That is the outlier. Number 19, which graph shows a function in which the rate of change and the y-intercept are both positive? So rate of change, I'm just going to look, the rate of change going down, that's a negative rate of change. That's out. This is up, so that's positive. So that might be the answer. This is up, so that's positive. This is down, so that's negative. So I'm just talking about the slope. So the downs are out. So it's either B or C. All right? So we know that this is up and this is positive. But it says that the y-intercept has to be positive. This is 0, 0. This is kind of like 2. That's positive. This is C is your answer. This is 0, 0. So that's not positive, or 0 is not positive or negative. This is out. C is your answer to number 19. All right. So number 20, the last multiple choice question that there is on this review sheet and on the test as well. Which equation represents the line in the graph or on the graph? So the only thing I don't like is that it's supposed to be arrows. All right, so the first thing that I always key on is, all right, I need the slope and the y-intercept, and the y-intercept is the easiest, so it's 5. That's not going to help me much because every single one of these equations has a y-intercept of 5. Okay, well, let's go for the slope next. This line from left to right goes down. And you know down represents a negative slope. If it's a negative slope, that means A, which is a positive slope, is out. Positive slope. Negative could be this. Negative could be this. This is positive. Out. So let's go ahead and draw my triangles, my triangle. So I am going to count down 1, 2, -2, and then 1. So my slope is -2 over 1. I knew this was negative already. Slope is -2, and the y-intercept is 5. B is your answer. Right? And that's it. Rise over run. Just don't forget, because if you don't write it, sometimes you'll put the wrong numbers, and the rise is -2 and the run is 1. All right, let's go on to number 21. Skipped one. A cab company charges a $30 boarding rate in addition to $10 for every mile. So by the way, number 21 is an open-ended question, so you have to show all of your work from here on in. All right. You should show all of your work anyway. Take your time. Cab company charges $30 boarding rate, and I'm going to erase that. That looks kind of sloppy. So I'm going to highlight the boarding rate and $10 for every mile. $10 for every mile. So what we say right now is the number that is getting charged over and over and over again is your slope. It's your rate. M equals 10. This boarding rate is the initial value. It's the number that gets charged before the cab even moves, right? $30 right away. And that is your B, which is your y-intercept. So B equals 30. So put that down right here. In rise over run format, because we're going to graph this, so it's important to put this in rise over run. So if it's $10, the M, what's the run? It's 1. The B is the boarding rate, is $30. So what we like to do right now, the rise is positive, so we're going to put directional arrows up, and the run is positive, so we're going to the right. Up is positive, down is negative. Right is positive, left is negative. All right, just like the number line. All right, so here we go. We're gonna put the equation of this line together. The slope is 10, the y-intercept is 30. Y equals mx plus b. 10x plus 30. Now it says graph the function. So I have two things here. I have dollars and miles. Miles represents the x. Miles. That's the independent variable. And dollars represents the y-axis. So I'm going to start with 0 miles and label and number my coordinate grid by ones. My x-axis by ones. But the dollars be a lot different. So what should I start at? Like when this person got into the cab, what did they have to pay as a rate before even moving? If you're saying 30, yeah, he or she had to pay $30, a boarding rate of $30. So that's what I'm going to start with. You see, like I'm going to start this y-axis at 30. And that's the reason why. The reason why is because nothing before 30 counts, or it matters. Doesn't matter. Because the person got into the cab and the cab driver said $30. So listing 20 or 10 or what, it doesn't even matter. So we're going to go up to 30 and then we're going to rise 10. We're going to use our slope and run 1. Rise 10, rise 10, rise 10. And you keep on counting by tens. You're setting your graph up to be easily constructed. Using your slope, you rise, using your slope. You start at the y-intercept. There's one thing missing. Since we skipped to 30 and then increased by tens, we have to have a break. And that is called a break. It's when you skip up to a number and then increase on the y-axis or the x-axis by a different amount. All right. If it's consistent, if it went up by 30s all the way, then you wouldn't need a break. But you went up by 30 and then increased by tens. So let's go ahead and graph this. We have this y-intercept starting at 0, 30. So 0, 30 is right here, and make a nice big point because that is your y-intercept. I'm going to put that in, no, I'm going to put that in blue. No, maybe not. I don't even know. All right, so that is 0, 30. Then we're going to rise 10, and since we already labeled the graph by tens, it's so nice, and run 1. Rise 10, run 1. And you keep on going like that. Rise 10, run 1. Up 10, to the right 1. And it's not like you're going up 10 boxes, 10 units. You're going up 1 because you already labeled that y-axis by tens. And you see how easy it is to go ahead and graph now. Now take your straight edge and connect those points just like that. Last thing, please get in the habit of doing this, put the equation on the line. What is the initial cost? The initial cost is $30. What is the rate? The rate is $10 per mile. And you can see it right up here, $10 for every mile, $30 boarding rate. So that's it. That's your graph. All right, and that is number 21. Number 22, Tim is selling tickets to a school sporting event to raise money for his club. He puts some extra money in his box before he began. As he sells tickets, he records the number of tickets he sold and the total amount of money in the box. Some of his data are shown below. So this is what they give us. Assuming all tickets are the same price, write an equation that represents the situation. In the table, part A, find the equation of the line represented in the table. Looking at your equation, how much money was initially in the box before he sold any tickets? So let's talk about the equation. The equation is y equals mx plus b. And since I do not know my b, I am going to find the slope. And I know that if I have a table of values, I'm going to put x1, y1, x2, y2. So y2 minus y1. I move that over. That's my slope formula. I'm going to set up my slope fraction line and the two minus signs, and I'm going to do 146.25, 146, wow, 0.25 minus 108.75. All right, so, and now I am going to do x2 minus x1. So my x2 is 13 and my x1 is 7. Calculator time. All right. So I am going to make sure I press this fraction button right there, 146.25 minus 108.75. Then down 13, press the down button, and 13 minus 7 or down arrow, and then press the right arrow, and we are pressing enter. We have 6.25. 6.25. All right. So I'm almost there. Y equals, I have the m. I have mx plus b. And then I have the m is 6.25. But I have no y-intercept. There's a couple of ways you can do this. I'm going to show you using the point slope formula, I have a slope and I have a point. I have a lot of points. So my point slope formula is y minus y1 equals m times x minus x1. So y minus y1 is 108.75 equals m is 6.25 times x minus x1, which is 7. I'm taking the labels I had already with the slope formula that I already used, the x1, y1, and I'm substituting it in here. So y minus 108.75 0.75, and to solve this, I have to do distributive property. So I do 6.25 times x, and I get 6.25x. That's where my slope comes in. And then 6.25 times -7. I'm going to grab the calculator up. 6.25 times -7. So -43, that is -43, -43.75. I'm going to keep that calculator up because I'm going to add 108. I'm solving for y. Once I solve for y, I am finished. So this cancels. And I am going to get -43.75 plus 108.75. 65. So y equals 6.25x plus 65. So I now have my y-intercept of 65, b equals 65, because I have my y equals mx plus b. So I use the point slope formula because I had a point and the slope right there. And now I can answer B. Looking at your equation, how much money was initially in the box before he sold any tickets? $65. In the box. Initially. All right, so we haven't gone over this yet in class, but this is another method. Whenever you're looking for the y-intercept, you could actually use y equals mx plus b instead of the point slope formula. After you solved for slope, right? So after we did the first method, we did the first, not method, but the first thing that we did was actually solve for slope. We solved for this slope right here. We got y2 minus y1 over x2 minus x1. We got 6.25. This, instead of doing point slope formula, a lot of people like this method, but I'll show you exactly what's going on. So the slope is 6.25, and we have y equals mx plus b. The y, you could pick any random y here, all right? But if you pick the y, just remember to pick the x that corresponds with the x and y, all right? So this is now my y, 108.75, and I got that from here, right? That's my y. And then I put equals, I'm following this formula, m is my 6.25. So I got this slope and I substituted it in. And then my x, when y is 108.75, that's x, the independent variable is the x, which is 7. And that's when I substituted it into here. I did 6.25 times 7 in my calculator. I do 6.25 times 7 in my calculator, and I get 43. Let me just put that down. 108.75 equals 6.25 times 7 is 43.75, and that's all plus b. Now, if I move this if I move this 43.75 over to this side, you have your y-intercept. So let me just go ahead and do that. I'm going to minus 43.75 from both sides. And guess what I get? 108.75 minus 43.75, I get 65 equals B. B equals 65. This is the second method that I was talking about. if you understand that and you need the y-intercept, you could either use the point slope formula, which is up here, or you could use method 2, which is just that y equals mx plus b that you already know. All right, substitute a y and an x from the table and the slope that you just figured out, and then solve for b, and you'll get your y-intercept. And this y-intercept is what is initially in the box. All right, so that's what was initially inside that box, and that's it. All right, number 23, use the linear function 6x plus 2y equals 10 to answer the following questions. Find the slope and y-intercept. So let's go ahead again and solve. This is not in y equals mx plus b. We need it in y equals mx plus b. Go ahead and solve. Minus 6x minus 6x. This cancels. You have 2y equals negative 6x plus 10. You divide by 2 on both sides, and you get y equals, I'm going to put that over here, y equals negative 6 divided by 2 is negative 3. Don't forget the x. And then 10 divided by 2, nice numbers, plus 5. So the rise over run, remember, put it in rise over run format. That negative 3, and a lot of people do this. Put the 1 underneath. That's your slope. That's your rate. Negative 3 over 1. Right? So now I'm going to put the directional arrows. Negative is going down 3. Positive is going to the right 1. And 10 divided by 2 is my 5. I'm going to start with that. All right, so let's go ahead. This is my starting point. All right, so I have 5, and I'm going to go, and this is, by the way, 0, comma 5. When x is 0, that other number is that y-intercept. So 0, 5 is all the way up here. I'm going to put a nice point there. Then I'm going to go down 3 and to the right 1. Down 3, 1, 2, 3, to the right 1. Down 3, 1, 2, 3, to the right 1. 1, 2, 3, to the right 1. Down 3, 1, 2, 3, to the right 1. And then one more. Down 3, to the right 1. I have to continue the pattern up here, fill in the whole entire graph. Up 3 instead of down, and to the left 1. Get your ruler out and connect those points. Just like that. If you make a mistake on the pattern, you'll be able to tell right off the bat that one point is not in that rise 3, run 1. All right, so if you make a mistake, you'll see one of these points that you have to swerve to hit or to connect. So that is your line. So I'm going to put y equals negative 3x plus 5. That's the equation of that line. So it says create an equation that is parallel to the equation graphed. Well, what do parallel lines have the same of? So parallel lines have the same slope and different y-intercept. So if you come up with y equals negative 3x plus 5 as this equation, whatever you put, you have to put the same slope, negative 3x, plus a different y-intercept. So this line right here would be parallel. Or you could put just y equals negative 3x. The y-intercept would be 0. And just take a look. If I graph this, if I start at 0, the b is 0. The slope is the same. It's negative 3 over 1. So I'm going down to the right. So down 3 to the right 1. Down 3 to the right 1. Oh, boy. Down 3 to the right 1. Down 3 to the right 1. Up 3. 1, 2, 3. To the left. Look at 1, 2, 3. When you have the same slope, these are parallel lines. See? And that is why when you have the same slope, you're going to have an exact pair of parallel lines. Right? You don't have to graph it on the test or anything like that. I'm just saying why, and this is showing you exactly why when you have the same slope and different y-intercept that you do come up with those parallel lines. I just wanted to come back, and this is really your official answer. And that was number 23. All right, so here we go. Write an equation in point-slope form that passes through the points, and then find the slope. So we use the point-slope formula. So find the slope for A. M equals y2 minus y1 over x2 minus x1. The slope formula right away. Then label x1, y1, x2, y2. You're going to use those labels in a lot of different formulas, right? You use them for the point-slope formula. You're using them for midpoint when you get into high school, figuring out midpoint. So here we go with the slope, and I'm going to set it up with minus sign and minus sign. I'm going to do y2, which is 8, minus 5. And then x2, which is 6, minus 5. I don't need my calculator for this one. This is 3 over 1. My slope is 3. You do not need the slope in rise over run format unless you are going to graph it. So now it says use the point slope formula, and we give you the point slope formula. How generous. All right? Point slope formula, y minus, and I'm going to take my y1. I'm going to use my same number here that I put for y1, which is 5. Equals the slope, which is 3, x minus x1, which is 5. Use the point-slope formula to find the equation in slope-intercept form. Right? I don't know why I'm crossing that out, but slope-intercept form. So the equation of a line in slope-intercept form. So by the way, I'm going to just put down so nobody gets confused. This is point-slope form. All right, just like this. That's point-slope form. So now I am going to get slope-intercept form. Slope-intercept form is the y equals mx plus b. So I'm going to rewrite this. And I'm going to do distributive property and solve for y. 3 times x and 3 times negative 5. So now I have y minus 5 equals 3x. 3 times negative 5 is negative 15. Then I add 5 on both sides. And I get y equals, actually I'll put it down here because this is slope-intercept form. y equals, this cancels, 3x minus 10. And that is slope-intercept form because it has the slope and the intercept in it. It has the m and the b. Slope-intercept form. This is point slope form. So if it asks you for both answers on the test, please make sure that you put both answers, correct answers, on the lines. So for this unit test, you need to know the following formulas. Equation of a line in slope-intercept form is y equals mx plus b. And that is slope-intercept form. Right? Because it has the slope in it. And remember, the m is the slope. And the b is that y-intercept. The slope formulas, when I say formulas, you need to know two of them, rise over run. And this is used when you have a graphed line. Best if used for a graphed line. The other slope formula, which is the same thing, y2 minus y1 over x2 minus x1. This is used when you're given two coordinate points, two or more coordinate points, used when you have coordinates. And remember, you label the coordinates. So the point slope formula is y minus y1 equals m times x minus x1. We even give this to you on the test itself. These are the formulas that you need to know. Keep them handy. Put them right beside you when you're taking the exam, and that's it. You'll do fine. All right? Thanks for watching.